all of you accepted what I wrote there on the screen and you're all pretty happy with it. You applied it. You might not have quite got there yet, but I think everyone's at least started question 4. Question 5 is the same as question 4, but with different numbers. Everyone was kind of okay with that. And all of you, not one person, not that I expected you to, not growling at you, not one person asked me a really important question about the angle. What would that question be? Yeah. So you need to pay attention. Make sure that you're focusing on what I'm talking about, because all of you were very happy to accept that X was an acute angle to start with. Yeah? I treated it like an acute angle. I didn't call it X hat for an acute reference angle or anything like that. You're very happy to do that. But X, of course, doesn't have to be an acute angle. X could be any old angle. Now, for the purposes of this next discussion, I'm going to assume it's an angle between 0 and 2 pi, because if it's beyond 2 pi, then it doesn't matter, right? We can rewind it back as many 2 pi's as we want to get it back to between 0 and 2 pi. So that's not so much of a point. Similarly, with a negative result, we can do a similar thing. So assume it's between 0 and 2 pi. I've been given that cos x is equal to 0.4. What does that mean about x, the angle? It doesn't just have to be acute. If it's acute, then it's in this quadrant. That's fine. But, someone fill in the sentence for me. Shaker, you want to say it? I know you do. It could also Gabe? I'll tell you why it can't be obtuse. And obtuse literally means in quadrant 2. If x was obtuse, what would that mean about this value here? It would have to be negative, right? But we are told that cos x is equal to positive 0.4. Could also, could one Charlie. So it could be here or here. Now, I'm just using this as an example. We could do the same thing with sine x equals another value. We could do sine of x equals a negative value or whatever else. But I'm just using this to illustrate. So cosine of x equals 0.4 means the angle could have been here or it could have been here. Okay, so let's assume, well, if it's acute, if it's in this area here, then it is exactly as I illustrated here. X is an acute angle, therefore it's just inside there. It's just inside there. For cos of negative x, it's just inside there. So we're good to go, right? So that's fine. So let's look at the alternative case, and that is what happens if cosine of x is, sorry, if x is a quadrant 4 angle. Then what we would have, well, let's have a look at cos of pi on pi plus x to start with. What we would have is that for x, we would have the angle in here somewhere, yeah? That's where x would be. So that's x. If I have pi plus x, then I am going to add pi to the value of x. So if I add pi to the value of x, aren't I just really just going all the way along here? Okay, so if it's hard for me to draw without making too scribbly. But if I've got x from here to here, then pi plus x is going to go from here to here. Okay? So if x goes to here, then adding a pi will mean that the final angle will be in this quadrant here. And what's the value of cosine in this quadrant? Negative. Treating x as if it were acute got it into this quadrant, but the value is negative in that quadrant anyway. Okay? Similarly, I'll try and draw it all together in a second. Similarly, if I look at cos of negative x, x, just the same as before, is a third quadrant angle, let's say. That's x. Then going backwards is going to make it go around the other way, right? So it's going to pass through 1, 2, 3 into the fourth quadrant, but it's going to do it backwards. So it's going to go 1, 2, 3 into the fourth quadrant backwards. And what's the value of cosine in the first quadrant? Positive. Flicking back to our screen, when we treated x as acute, it ended up being in the fourth quadrant where cosine is positive. So long story short, whatever the value of x is, we might as well treat it like an acute angle because it'll end up being in the same quadrant anyway. Okay? So it's a really important point to make and to understand, because when we start looking at adding things other than pi or 0 or 2 pi, in other words, when we start changing it from angles added, subtracted from an x-axis to angles added and subtracted from a y-axis, we're going to have to change the story up. But it turns out that for angles added and subtracted from an x-axis, that means added or subtracted from 0, added or subtracted from pi, added or subtracted from 2 pi, added or subtracted from 3 pi, added or subtracted from, etc. Okay, so whenever it's added or subtracted from the x-axis, you can treat the angle like an acute angle. It's not necessarily acute, but you can treat it like an acute angle. Okay, does anyone have any questions on that?